In a galaxy not so far away, science fiction meets science fact. For over 45 years, Star Wars has captivated our imagination with incredible technology and fascinating phenomena. But how much of it could actually exist? Where does fantasy end and scientific possibility begin? Today's scientists and engineers are pushing the boundaries of what's possible, and their discoveries might surprise you. From quantum physics to advanced robotics, from plasma weapons to artificial intelligence, the line between science fiction and science fact grows thinner every day. We're already developing plasma containment systems that echo lightsaber technology. Our quantum computers are revealing strange connections in the universe that almost seem like a force. Our artificial intelligence systems are becoming more sophisticated than C-3PO could have imagined. The Star Wars universe presents us with extraordinary technologies and phenomena that seem to defy our understanding of science. Yet many of these fantastic elements have startling parallels in real scientific research. Imagine the power required to destroy an entire planet like the Death Star. We can actually calculate that. Consider the possibility of faster-than-light travel through hyperspace. Our physicists are already exploring theories about folding space-time. Picture the floating cities of Bespin. We're developing technologies that could one day make cities in the sky a reality. Leading experts in physics, engineering, biology, and astronomy have long studied these possibilities. Their work reveals surprising truths about what's possible within the laws of our universe. Some Star Wars technologies might be closer to reality than you think, while others might forever remain in the realm of science fiction. The answers often challenge our expectations and push us to think bigger about humanity's potential. We'll explore questions that have intrigued scientists and fans alike for generations. How could a lightsaber contain its plasma blade? What would it really take to build and power a Star Destroyer? Could Bacta Tanks revolutionize medicine? Is there any scientific basis for the Force? From the smallest quantum particles to the largest starships, from the frozen wastes of Hoth to the desert dunes of Tatooine, we'll examine the real science behind these iconic elements. The exploration of Star Wars science takes us to the very edges of human knowledge. It challenges us to question what we know about physics, biology, engineering, and our universe itself. Through 16 fundamental aspects of the Star Wars galaxy, we'll discover how science fiction has inspired real scientific advancement and how today's discoveries might bring us closer to the technologies we once thought impossible. Welcome to Star Wars Science. The lightsaber stands as perhaps the most iconic weapon in science fiction, a blade of pure energy that can cut through nearly anything, yet somehow stops at its tip. But could such a weapon actually exist? The answer lies in the fascinating intersection of plasma physics, magnetic field manipulation, and power generation technology. Let's start with what a lightsaber blade actually is: contained plasma. Plasma, often called the fourth state of matter, occurs when gas becomes so hot that electrons separate from their atoms, creating a soup of charged particles. We see plasma naturally in lightning strikes and the surface of the sun. The blade of a lightsaber would need to be plasma heated to temperatures approaching 20,000 degrees Celsius, hot enough to slice through metal like a hot knife through butter. But herein lies our first challenge: containing this devastating energy. Uncontrolled plasma would simply expand outward, creating something more like a flamethrower than a sword. The solution might lie in magnetic containment fields, similar to those used in experimental fusion reactors. These powerful electromagnetic fields can shape and contain plasma in specific configurations. Current technology already demonstrates this principle. The ITER fusion reactor uses magnetic fields to contain plasma at temperatures hotter than the sun's core. The lightsaber would need to generate a magnetic bottle effect, a cylindrical magnetic field that contains and shapes the plasma into that distinctive blade shape. This magnetic field would need to be incredibly precise, strong enough to contain the plasma, but not so strong that it attracts nearby metal objects. The field would also need to terminate abruptly at the blade's tip, explaining why lightsabers don't extend infinitely. Power generation presents another fascinating challenge. The energy requirements for a lightsaber would be staggering. To maintain a plasma blade at the necessary temperature while powering the magnetic containment field would require approximately 1.69 megawatts of continuous power, enough to power about 1,400 homes. This power would need to come from a source small enough to fit within the lightsaber's hilt. Modern compact power solutions fall far short. The most advanced batteries we have today would deplete in seconds trying to power a lightsaber. However, recent developments in quantum energy storage and microscale nuclear fusion might offer hope. Scientists at various institutions are developing nuclear batteries the size of a sugar cube, capable of providing continuous power for decades. While still far less powerful than what a lightsaber would need, this technology points to possible future developments. The blade's ability to deflect other lightsaber blades presents another intriguing physics puzzle. When two magnetic containment fields interact, they would indeed repel each other, creating that characteristic clash we see in the films. This interaction would generate spectacular visual and auditory effects as the plasma fields compress and decompress rapidly. The color variation between lightsabers might actually have a basis in real physics. Different gases, when turned into plasma, emit different colors of light. Neon produces red, argon creates blue, and krypton generates a purple glow. The crystal focusing system mentioned in Star Wars lore could theoretically be a complex electromagnetic focusing apparatus that ionizes different noble gases. The humming sound of a lightsaber also has scientific merit. Plasma contained within magnetic fields naturally produces sound waves as the charged particles oscillate. The distinctive hum could result from the resonant frequency of the magnetic containment field interacting with the plasma stream. Recent breakthroughs in materials science offer tantalizing possibilities for future lightsaber development. Metamaterials, artificially structured materials with properties not found in nature, could potentially help create more efficient magnetic containment fields. Superconducting materials, which can carry electric current with zero resistance, might solve some of the power distribution challenges within the hilt. The greatest hurdle in creating a real lightsaber remains heat management. Even with perfect magnetic containment, the hilt would need to handle enormous heat dissipation. Current materials would melt almost instantly. However, new carbon-based materials like graphene show promise in extreme heat management, potentially offering a solution to this thermal challenge. Looking to the future, while a fully functional lightsaber remains beyond our current technological capabilities, many of its individual components are slowly moving from science fiction toward science fact. Advances in plasma physics, magnetic field generation, power storage, and materials science are gradually bringing us closer to understanding how such a weapon could theoretically function. You know that incredible moment when stars stretch into brilliant streaks of light and the Millennium Falcon vanishes into hyperspace. It's one of the most memorable visuals in science fiction, but here's what's really fascinating. We might not be as far from that reality as you'd think. Now, I know what you're thinking. Einstein told us nothing can travel faster than light. And he's absolutely right. Light zips through space at a mind-bending 299,792 kilometers per second. To put that in perspective, even at that incredible speed, it would take over 4 years to reach our closest neighboring star, Alpha Centauri. No wonder the Empire needed a faster way to get around. But here's where things get really interesting. Einstein showed us something else that changes everything. Space and time aren't separate things at all. They're more like a fabric, what we call space-time. And this fabric, it can bend, warp, and possibly even fold. We can actually see this happening around massive objects like stars and black holes. The more massive the object, the more it warps the space around it. Think about it this way. Imagine you're an ant walking across a piece of paper. Going from one corner to the opposite corner is quite a journey. But what if you could fold that paper, bringing those corners together? Suddenly, that long journey becomes a single step. That's exactly what hyperspace travel might be. Not breaking Einstein's speed limit, but taking a clever shortcut through the fabric of space itself. There's this brilliant physicist, Miguel Alcubierre, who took this idea and ran with it. He came up with actual mathematical equations showing how we might create a bubble in space-time around a spacecraft. Picture this. The space in front of the ship squeezes together while the space behind stretches out. The ship itself isn't moving faster than light, but it's surfing through space-time like a cosmic wave rider. Sound familiar? It's remarkably similar to how the Millennium Falcon seems to create that hyperspace tunnel. But, and there's always a but in cutting-edge science, the engineering challenges are absolutely mind-boggling. When Alcubierre first worked out the math, the energy required was more than exists in the entire observable universe. That's not great for our hyperspace dreams. The good news? Recent calculations have brought that number down significantly. The bad news? We'd still need something we've never found. Matter with negative mass. Don't give up hope, though. Quantum physics, that weird and wonderful realm of the very small, might have some answers. There's this bizarre thing called the Casimir effect, where quantum fluctuations create tiny regions of negative energy density. We're talking incredibly small amounts, nowhere near what we'd need for hyperspace travel. But it proves something profound. Manipulating space-time might not be impossible after all. You know how Han Solo always talks about the importance of precise calculations? Turns out he's absolutely right. If we ever create hyperspace tunnels, we'd need to account for the gravitational effect of every single massive object along the route. One wrong calculation, and you could end up inside a star. The computing power needed would be astronomical, no pun intended. Well, maybe a little intended. Here's something even wilder. Space itself is expanding, driven by this mysterious force we call dark energy. Some physicists think that if we could harness this dark energy, we might be able to create controlled regions of space-time expansion and contraction. Imagine that, using the same force that's pushing our universe apart to power our very own hyperspace drives. Recent discoveries about quantum entanglement add another layer of intrigue. We've observed particles that seem to influence each other instantaneously across any distance, apparently thumbing their nose at light speed. While we can't use this for direct travel yet, it hints at deeper aspects of space-time we're just beginning to understand. Are we going to be making the Kessel Run in 12 parsecs anytime soon? Probably not. But every time we detect a gravitational wave, every time we make a breakthrough in quantum physics, we're pulling back the curtain on how space-time really works. And maybe, just maybe, we're taking our first steps toward that galaxy, far, far away. I felt a great disturbance in the Force, as if millions of voices suddenly cried out in terror and were suddenly silenced. Obi-Wan Kenobi's famous words hint at something quantum physics is just beginning to understand: the possibility of instant connections across vast distances of space. When Obi-Wan sensed the destruction of Alderaan from across the galaxy, he was experiencing something eerily similar to quantum entanglement. At the quantum level, particles can become linked in such a fundamental way that measuring one instantly affects the other, regardless of the distance between them. Einstein called this spooky action at a distance, and like many aspects of the Force, it seems to defy our conventional understanding of the universe. The most dramatic demonstration of this came in 2017, when scientists used a satellite named Messius to prove quantum entanglement works across more than 1,200 kilometers. While not quite the galaxy-spanning awareness of a Jedi Master, this experiment showed that instant connections between distant points are not only possible, but measurable. When Luke sensed Vader's presence on Endor, or when Vader sensed Obi-Wan aboard the Death Star, they might have been tapping into something similar to these quantum connections. Force users' ability to sense the future, like Luke's visions on Dagobah or Anakin's premonitions, might connect to another bizarre quantum phenomenon called retrocausality. Recent experiments at the Hebrew University of Jerusalem have shown that quantum effects can appear to influence the past. While controversial, these studies suggest that quantum particles can affect each other backward in time. The quantum world, like the Force, seems to transcend our normal understanding of cause and effect. Consider Force lightning, one of the most spectacular dark side abilities. While shooting lightning from one's hands remains firmly in the realm of science fiction, quantum physics reveals that empty space is actually filled with enormous amounts of energy. Each cubic centimeter of vacuum contains enough theoretical energy to boil all Earth's oceans. If a Force user could somehow tap into this quantum vacuum energy, perhaps something like Force lightning wouldn't be impossible. After all, we regularly observe quantum fluctuations creating particles and energy from seemingly nothing. The Jedi's legendary telekinetic abilities might find a distant cousin in quantum levitation. When certain materials are cooled to extremely low temperatures, around -280 degrees Fahrenheit, quantum effects can cause them to levitate above magnetic fields. While this is far from lifting X-wings out of swamps, it demonstrates how quantum effects can produce seemingly impossible physical phenomena. Recent experiments at MIT have even shown quantum effects influencing larger objects, though still far smaller than spacecraft. One of the most mysterious Force abilities is the power to influence minds. These aren't the droids you're looking for might seem like pure fantasy, but quantum mechanics suggests consciousness and reality are more intertwined than classical physics indicates. The quantum Zeno effect shows that merely observing a system can prevent it from changing, consciousness literally affecting reality at the quantum level. While this falls short of Jedi mind tricks, it hints at deeper connections between mind and matter. Force ghosts, like the apparitions of Obi-Wan, Yoda, and Anakin, might relate to quantum immortality, a mind-bending implication of quantum mechanics suggesting consciousness might persist across multiple quantum states. While highly theoretical, the idea emerges from the many worlds interpretation of quantum mechanics, where every possible quantum outcome exists in its own reality. When Luke and Vader sense each other's presence across vast distances, they demonstrate something quantum physicists call quantum non-locality. In 2022, researchers created a network of 20 entangled quantum bits that could instantly influence each other. While far from a force-like connection between living beings, it shows how quantum systems can maintain instant connections across space. The concept of force sensitivity itself might have a quantum explanation. Some scientists propose that consciousness arises from quantum processes in cellular structures called microtubules. If true, perhaps force-sensitive individuals simply have a greater natural ability to tap into these quantum processes. This could explain why force sensitivity often runs in families. It might be linked to specific genetic traits that enhance quantum interactions in neural tissue. The unified nature of the Force, its light and dark sides existing in balance, mirrors quantum complementarity. In quantum mechanics, particles can exist in multiple states simultaneously until measured, just as the Force encompasses seemingly contradictory aspects of creation and destruction. This quantum superposition might explain how the Force can have seemingly opposite aspects that remain fundamentally connected. In Attack of the Clones, Yoda describes how everything is connected through the Force. Quantum entanglement experiments have shown that particles can be connected in groups, forming quantum networks where changing one particle instantly affects all others. The record for quantum entanglement now stands at thousands of particles, all instantly interconnected. While far from connecting all living things, it shows how vast networks of quantum connections are possible. Battle meditation, a rare force power used by strategists like Bastila Shan, might relate to quantum coherence in biological systems. Scientists have discovered that birds use quantum entanglement to navigate using Earth's magnetic field, and some bacteria use quantum effects to make photosynthesis more efficient. These discoveries suggest that nature has been using quantum effects in living systems for billions of years. When Jedi speak of disturbances in the Force, they might be describing something similar to quantum field perturbations. We now know that quantum fields permeate all space, and disturbances in these fields can propagate across the cosmos. The 2015 detection of gravitational waves showed how space-time itself can ripple with information about distant events, not unlike how the Force carries information about significant disturbances to those sensitive to it. The Force flows through all living things, an idea that seems mystical until we consider quantum biology. Recent studies show that quantum effects play crucial roles in biological processes, from photosynthesis to enzyme activity. The quantum nature of life itself suggests that all living things are indeed connected through fundamental quantum processes. Perhaps most intriguingly, the Jedi's emphasis on calmness and focus during Force use parallels the importance of controlled conditions in quantum experiments. Quantum states are notoriously fragile, easily disrupted by outside interference, much like how emotional turmoil can disrupt a Jedi's connection to the Force. The most powerful Force abilities, like Yoda lifting the X-Wing, require intense concentration, just as the most impressive quantum effects require precisely controlled conditions. That's no moon, it's a space station. While Obi-Wan was describing the Death Star, his words capture the sheer scale of Imperial engineering. The Star Destroyer, stretching 1.6 kilometers from bow to stern, represents an engineering challenge that pushes against the very limits of physics. Yet modern science is beginning to understand how such massive vessels might one day be possible. When the Millennium Falcon first encounters the Star Destroyer Avenger, we see millions of tons of starship changing direction with impossible grace. This mastery over mass and inertia hints at revolutionary materials that we're just beginning to discover. Modern laboratories have created carbon nanotubes, microscopic structures 100 times stronger than steel, while weighing only 1/6 as much. While we're far from building Star Destroyer-scale structures, these materials show how the Empire's massive ships could maintain structural integrity during complex maneuvers. The moment when the Imperial fleet emerges from hyperspace at the Battle of Endor presents another fascinating puzzle. Those vessels are experiencing forces that should tear them apart, yet they remain intact. Recent breakthroughs in metamaterials, substances engineered at the molecular level, suggest how this might be possible. Scientists have created materials that can absorb and redistribute energy in ways that seemed impossible just decades ago, much like the structural integrity fields that protect Imperial vessels. Admiral Piet's command of the Superstar Destroyer Executor demonstrates another engineering marvel: the ability to maintain artificial gravity for tens of thousands of crew members. While modern space stations rely on rotation to simulate gravity, Imperial vessels somehow generate gravitational fields throughout their massive hulls. Recent quantum experiments have detected unexpected gravitational effects at small scales, suggesting our understanding of gravity might be far from complete. Perhaps the Empire's mastery of gravity isn't as impossible as it seems. The iconic scene of Star Destroyers hovering over Jeddah City showcases perhaps their most impressive feat: atmospheric flight. Keeping millions of tons suspended against planetary gravity would require incredible energy output. While our current ion engines can operate continuously for years, producing thrust with unprecedented efficiency, they generate only a fraction of the power needed. Yet recent breakthroughs in fusion research at the National Ignition Facility hint at how such enormous energy requirements might one day be met. When Captain Neda's Star Destroyer executes a precise Imperial search pattern, we're witnessing computers handling calculations that would overwhelm today's most advanced systems. Yet quantum computing is beginning to show how such massive computational tasks might be possible. Recent experiments have created networks of quantum bits that can perform certain calculations faster than the most powerful classical computers ever built. The devastating barrage from Star Destroyers during the Battle of Hoth reveals another engineering challenge: power generation on an unimaginable scale. Those turbo-laser batteries require more energy than Earth's entire power grid produces in a day. While this seems impossible, the quantum vacuum itself contains staggering amounts of energy. Each cubic centimeter of empty space theoretically contains enough energy to boil Earth's oceans. Imperial engineers might have found ways to tap into this cosmic energy reserve. Perhaps most impressively, when the Star Destroyer Devastator captures Princess Leia's corvette, we see tractor beam technology that seems to defy physics. Yet modern laboratories have created optical tweezers using focused light to manipulate tiny objects, and acoustic tractor beams that can lift small items using sound waves. While far from capturing starships, These demonstrations show how matter can be manipulated at a distance through fundamental forces. The massive shield generators protecting Imperial vessels, capable of absorbing both energy weapons and physical impacts, might relate to recent advances in plasma physics. Scientists have created small-scale magnetic shields that can deflect charged particles and radiation, offering a glimpse at how energy shields might function. When the Millennium Falcon bounces off the Executor's shield during the Battle of Hoth, we might be seeing an advanced version of these same principles. The Star Destroyer's distinctive wedge shape isn't just for intimidation. It represents a perfect marriage of form and function. Those angular surfaces help deflect incoming fire while distributing structural loads, much like how modern metamaterials use geometric patterns to control energy and force distribution. When Rebel fighters attack the bridge of the Executor, those shots glance off the sloped armor, demonstrating this principle in action. Fire when ready. With these 3 words, Grand Moff Tarkin demonstrated the most devastating weapon ever conceived, a battle station capable of destroying an entire planet. The moment Alderaan shattered into cosmic dust represents energy requirements so vast they challenge our understanding of physics itself. Yet modern science offers intriguing hints at how such power might theoretically be harnessed. When the Death Star's superlaser struck Alderaan, it delivered enough energy to overcome the planet's gravitational binding energy, the force holding every atom of the planet together. Scientists have calculated that destroying an Earth-sized planet would require approximately 2.25 times 10 to the 32nd joules. To put this incomprehensible number in perspective, this is more energy than our sun produces in an entire week. Yet somehow, the Death Star generated this power in a matter of seconds. The green glow of the Death Star's primary weapon hints at how this might be possible. When we watch those 8 beams converge into a single devastating blast, we're seeing what Imperial engineers called a superlaser. But the principles behind it might not be entirely fictional. Modern physics labs have achieved similar beam convergence using arrays of high-powered lasers. The National Ignition Facility uses 192 laser beams to create conditions similar to those found in stars, focusing them on a target smaller than a pencil eraser. During the Battle of Yavin, we see the Death Star preparing to fire on the Rebel base. The station's power systems begin a distinctive charging sequence, creating a visible energy buildup before release. This matches our current understanding of how such massive energy weapons might work. Recent experiments with pulse power systems have achieved incredible energy storage and release rates, though at far smaller scales. The Z machine at Sandia National Laboratories can briefly generate more power than all the world's power plants combined, offering a glimpse at how energy might be accumulated and released for weapon systems. The Death Star's reactor core, glimpsed briefly in schematics stolen by the rebels, suggests an energy source beyond conventional physics. While modern nuclear reactors harness the power of fission, and experimental fusion reactors attempt to replicate the sun's power, the Death Star would require something far more exotic. One possibility lies in antimatter reactions. When matter and antimatter annihilate, they convert their entire mass into pure energy with perfect efficiency, the ultimate power source predicted by Einstein's famous E equals mc squared equation. Director Krennic's pride in the Death Star's capabilities was well-founded. During the destruction of Jeddah City, we see a significantly reduced power test that still carries enough energy to devastate a planetary surface. This level of power control is remarkable, like having a weapon that can be tuned from destroying a continent to shattering a planet. Modern directed energy weapon research shows similar principles of scalability, though at far lower power levels. The United States Navy's laser weapon systems can be adjusted from dazzling sensors to destroying small boats. The Death Star's power distribution system, capable of channeling planet-destroying energies through the station, represents another engineering marvel. When those 8 green beams converge, they're carrying more power than flows through Earth's entire electrical grid in a year. Recent breakthroughs in superconductivity offer hints at how this might work. In 2023, scientists achieved room-temperature superconductivity under specific conditions, materials that can carry enormous electrical currents without resistance or energy loss. Perhaps most impressively, the Death Star contains this apocalyptic power without destroying itself. When we see the station's reactor core in Return of the Jedi, we're looking at a containment system that would have to manage energies beyond anything we can currently create. Yet modern physics is beginning to understand similar challenges. Inertial confinement fusion experiments use magnetic fields to contain plasmas hotter than the surface of the Sun, suggesting how Imperial engineers might handle such extreme energies. The precision timing required to converge 8 separate beams into a single planet-destroying blast represents another fascinating challenge. When we watch those beams combine during Alderaan's destruction, we're seeing synchronization at the subatomic level. Modern laboratories achieve similar precision with laser arrays, using computerized timing systems accurate to femtoseconds, millionths of a billionth of a second. The Large Hadron Collider demonstrates similar precision, coordinating particle beams traveling at nearly the speed of light. The Death Star's Kyber crystal array, essential to amplifying and focusing its incredible energies, might have parallels in modern physics. While we can't replicate the mystical properties of Kyber crystals, recent experiments with photonic crystals have demonstrated remarkable abilities to control and amplify light. Quantum metamaterials, artificial structures that manipulate light at the quantum level, show how energy beams might be amplified and controlled with unprecedented precision. When Galen Erso designed the reactor's fatal flaw, he was working with energies that could tear space-time itself. Modern physics suggests that concentrating enough energy in a small space could actually create a microscopic black hole. The Death Star's reactor core may have been approaching these theoretical limits. Recent calculations suggest that creating a microscopic black hole would require less energy than destroying a planet, though still far beyond our current capabilities. The Death Star's ability to power its superlaser while maintaining life support, artificial gravity, and other systems for millions of crew members represents an incredible feat of power management. The station would need multiple redundant power distribution systems, each handling energies beyond anything we can currently generate. Recent advances in smart power grids offer primitive examples of how such complex power management might work, using artificial intelligence to balance loads and prevent cascading failures. Sir, it will take quite a while to evacuate the wounded. The Empire Strikes Back's opening moments on Hoth reveal one of Star Wars' most fascinating technologies, the Bacta Tank, a medical miracle that can heal devastating injuries in days rather than months. When we later see Luke Skywalker floating in this healing fluid after his near-fatal encounter with a Wampa, we're witnessing technology that modern medicine is just beginning to approach. The most dramatic demonstration of Bacta's power comes after Anakin Skywalker's devastating injuries on Mustafar. While the burns and trauma he suffered would be fatal by today's standards, Imperial medical technology kept him alive long enough for Bacta treatment. Modern medicine is making surprising strides in this direction. Recent breakthroughs in regenerative medicine have shown how stem cells suspended in specialized solutions can regenerate damaged tissue. In 2023, scientists successfully created lab-grown skin that includes blood vessels and nerve endings, a small step toward Bacta-like healing capabilities. When we see Boba Fett emerge from a Bacta tank in the Book of Boba Fett, decades of accumulated injuries being systematically repaired, we're witnessing something similar to emerging therapeutic approaches. Modern researchers have developed hydrogels that can deliver healing factors directly to wounded tissue. These advanced materials create microenvironments that promote healing, much like how Bacta provides an optimal environment for cellular regeneration. Recent experiments have shown these hydrogels can speed healing by up to 60% in some cases. The breathing apparatus used in Bacta tanks hints at another fascinating aspect of their operation. Patients remain conscious yet peaceful during treatment, similar to a meditative state. Modern medical science is exploring similar technologies through liquid ventilation, breathing fluids that can carry oxygen directly to the lungs. While currently experimental, these perfluorocarbon-based breathing liquids have shown promise in treating severe respiratory conditions. The United States Navy has even investigated their use for deep-sea operations, suggesting how a Bacta-like breathable fluid might work. Perhaps most impressively, when Din Djarin uses a portable Bacta spray in The Mandalorian, we see how this technology can be miniaturized. While we can't yet replicate this capability, recent advances in nanomedical delivery systems show promise. Scientists have developed microscopic particles that can carry healing factors directly to injured tissue. These nanocarriers can be suspended in sprays or gels, delivering their therapeutic payload precisely where needed. In 2022, researchers successfully used similar technology to speed wound healing in diabetic patients. The scene of Luke's Bacta treatment on Hoth reveals another fascinating aspect: the tank's ability to maintain precise temperature control while delivering therapeutic compounds. Modern medicine is developing similar capabilities through targeted hypothermia treatments. By carefully controlling local temperature and delivering specific proteins and growth factors, doctors can now enhance the body's natural healing processes. Recent trials have shown this approach can significantly speed recovery from certain types of injuries. Bacta's ability to heal nerve tissue, demonstrated when Luke recovers sensation in his face after the Wampa attack, represents one of its most remarkable capabilities. While we can't yet regenerate nerves this effectively, recent breakthroughs offer hope. Scientists have developed bioactive scaffolds that guide nerve regeneration, while electrical stimulation techniques can help maintain nerve function during healing. In 2023, researchers successfully regenerated severed nerve connections in laboratory tests using a combination of these approaches. The rapid tissue regeneration seen in Bacta tanks might relate to emerging research in bioelectric medicine. When we watch damaged tissue knitting itself back together during treatment, we're seeing accelerated healing that modern science is beginning to understand. Recent studies have shown that manipulating the natural electrical fields in tissue can dramatically speed healing. Scientists have successfully used bioelectric stimulation to regenerate limbs in amphibians, suggesting how Bacta might accelerate natural healing processes. During the Clone Wars, we see Bacta Tanks being used to treat massive combat injuries, demonstrating their ability to prevent infection while promoting healing. Modern medicine is developing similar capabilities through smart bandages that can detect and fight infection while delivering healing factors. Recent advances in antimicrobial hydrogels show how a healing environment can actively protect against pathogens. Some of these materials can even adapt their therapeutic response based on the type of infection present. The suspended animation-like state of Bacta Tank patients hints at another frontier of modern medicine. While patients remain conscious, their metabolic processes are carefully controlled to optimize healing. Current research into therapeutic hypothermia shows similar principles. Carefully lowering body temperature can help protect tissues during healing. Hospitals now routinely use this technique to protect patients after cardiac arrest, showing how controlling the body state can enhance recovery. When we see Bacta Tanks monitoring and adjusting their treatment in real time, we're witnessing sophisticated medical artificial intelligence at work. Modern medicine is moving in this direction through smart medical devices that can continuously monitor patient conditions and adjust treatment accordingly. Recent developments in artificial intelligence-driven medical systems can now predict complications before they occur and automatically adjust therapy parameters. The ability of Bacta to heal such a wide range of injuries suggests it works at the cellular level, promoting natural healing processes rather than forcing rapid regeneration. Modern regenerative medicine is discovering similar principles. Recent research into extracellular matrices, the natural scaffolds between cells, shows how providing the right environment can enable remarkable healing. Scientists have used decellularized matrices to regrow complex tissues, demonstrating how supporting natural healing processes can achieve remarkable results. Bacta's effectiveness across different species, from humans to Wookiees, hints at its fundamental interaction with cellular biology. While we haven't achieved this versatility, recent breakthroughs in evolutionary medicine are revealing common healing pathways across different species. Understanding these shared biological mechanisms might eventually lead to more universal healing technologies. I suggest a new strategy, R2. Let the Wookiee win. C-3PO's famous advice to R2-D2 demonstrates something remarkable. Not just artificial intelligence, but artificial wisdom. The droids of Star Wars display a form of consciousness that computer science is only beginning to understand. From R2-D2's clever problem-solving to K2SO's dry wit, these mechanical beings hint at possibilities that modern AI researchers are just starting to explore. When R2-D2 interfaces with the Death Star's computer system, we see something far beyond simple data access. The little astromech demonstrates contextual understanding, creative problem-solving, and even emotional investment in the outcome. While today's AI can process vast amounts of data, we are just beginning to approach this level of adaptive intelligence. Recent breakthroughs in large language models have shown how AI can understand context and generate creative solutions, though still far from R2's capabilities. The moment when C-3PO realizes the hyperdrive has been deactivated on Cloud City reveals another fascinating aspect of droid intelligence: the ability to integrate multiple types of information and reach insightful conclusions. Modern AI is making strides in this direction through multimodal learning systems. In 2023, researchers developed AI models that can simultaneously process visual, textual, and audio information, approaching the kind of integrated understanding demonstrated by protocol droids. L337's passionate advocacy for droid rights in Solo raises profound questions about machine consciousness. Her self-awareness and ethical reasoning suggest a form of consciousness that philosophers and scientists still debate. Recent developments in artificial neural networks have shown surprising emergent properties, patterns of activity that seem to arise spontaneously, similar to how consciousness emerges from biological brains. While we're far from creating truly self-aware AI, these discoveries hint at how machine consciousness might develop. The battle droids of the Trade Federation demonstrate another aspect of artificial intelligence, the ability to coordinate complex actions across large groups. While their individual intelligence might be limited, their networked operations show sophisticated swarm behavior. Modern robotics is exploring similar concepts through swarm intelligence research. In 2022, scientists successfully demonstrated groups of autonomous robots that could coordinate their actions to solve complex tasks, much like how battle droids work together in combat. K2SO's ability to calculate odds and adapt plans in real time during the Scarif mission shows advanced probabilistic reasoning. While his famous pessimism might be a personality quirk, his ability to constantly update risk assessments matches current developments in AI decision-making. Modern machine learning systems use similar probabilistic approaches, constantly updating their models based on new information. Recent advances in reinforcement learning have created AI that can adapt strategies in real time, though not yet with K2SO's versatility. When we watch BB-8 navigate complex social situations, showing clear personality and emotional intelligence, we're seeing something modern AI researchers call affective computing. While current robots can recognize and respond to human emotions, BB-8's natural social integration represents a higher level of emotional intelligence. Recent breakthroughs in social robotics have created machines that can engage in more natural interactions, reading and responding to subtle social cues in ways that hint at how droids might develop distinct personalities. The medical expertise of two 1B surgical droids capable of performing complex procedures and making critical decisions represents another frontier in artificial intelligence. Modern medical AI is beginning to show similar capabilities, though more limited. In 2023, AI systems successfully diagnosed complex conditions and assisted in surgical planning, showing how machine intelligence might eventually approach the capabilities of Star Wars medical droids. Recent developments in robotic surgery, where machines can make precise movements while adapting to unexpected situations, suggest paths toward more autonomous medical systems. Chopper's ability to handle complex starship systems while maintaining a distinct and rather cranky personality hints at how specialized knowledge might coexist with general intelligence. Modern AI research is exploring this through artificial general intelligence studies. While current AI systems excel at specific tasks, combining specialized expertise with general intelligence remains a significant challenge. Recent work in transfer learning, where AI systems can apply knowledge from one domain to another, suggests how droids might develop both deep expertise and broader intelligence. The memory wipes periodically performed on droids raise intriguing questions about machine consciousness and personality development. When C-3PO's memories are restored in The Rise of Skywalker, we see how a droid's experiences shape their personality and capabilities. Current research into artificial neural networks shows similar properties. The way these systems develop is heavily influenced by their training data or experiences. Recent experiments in continual learning, where AI systems can learn and adapt, without losing previous knowledge, hint at how droid personalities might develop and persist. Mouse droids scurrying through Imperial corridors demonstrate sophisticated autonomous navigation and obstacle avoidance. While simple compared to protocol droids, their ability to navigate complex changing environments represents a fundamental challenge in robotics. Recent advances in SLAM, simultaneous localization and mapping, technology have created robots that can build and update maps of their environment in real time, similar to how mouse droids navigate star destroyers. The varied levels of droid intelligence, from simple repair units to sophisticated protocol droids, mirror current discussions about AI architecture. Modern researchers debate different approaches to building intelligent systems, from narrow AI focused on specific tasks to more general systems that can handle a range of challenges. Recent developments in hierarchical AI architectures, where simple systems combine to create more complex behaviors, suggest how different levels of droid intelligence might emerge. Perhaps most intriguingly, the droids of Star Wars demonstrate genuine learning and growth. When R2-D2 develops new solutions to problems, or C-3PO adapts to unexpected situations, we're seeing machines that can truly learn from experience. Modern machine learning is approaching this through developments in unsupervised learning and reinforcement learning. Recent breakthroughs have created AI systems that can learn from their environment without explicit programming, showing how droids might develop new capabilities through experience. Hokey religions and ancient weapons are no match for a good blaster at your side, kid. Han Solo's confidence in his trusty DL-44 wasn't just bravado. Star Wars blasters represent a fascinating intersection of plasma physics, particle acceleration, and energy containment, technologies that modern science is beginning to understand. When we watch those distinctive red and green bolts streak across the screen, we're seeing theoretical physics made manifest. The moment when Kylo Ren freezes a blaster bolt in mid-air presents one of the most intriguing glimpses at how these weapons actually work. We see a coherent bolt of energy, suspended and visible, suggesting some form of contained plasma. Modern physics laboratories have achieved similar, though far less dramatic, results. In 2023, scientists successfully contained plasma in magnetic fields for several minutes, demonstrating how energy might be held in a coherent form. While far from Star Wars capabilities, these experiments show how energy weapons might eventually become possible. When Imperial stormtroopers blast their way into the Tantive 4's corridor, their E-11 blasters demonstrate another fascinating aspect of this technology: the ability to maintain coherent energy bolts over distance. While current-directed energy weapons tend to disperse quickly, recent breakthroughs in plasma physics suggest how this might be overcome. Researchers have discovered ways to create self-containing plasma filaments that can travel significant distances without dispersing, similar to how blaster bolts maintain their form through air. The distinctive colors of blaster bolts, red for Imperial weapons, green for Rebel ones, hint at different gas mixtures used to create the plasma. Modern plasma physics shows similar principles where different gases produce distinct colors when ionized. Recent experiments with plasma containment have used various noble gases, each producing characteristic colors when energized. While we can't yet create weapon-grade plasma bolts, we can create and study similar states of matter in laboratory conditions. Din Djarin's demonstration of different blaster settings in The Mandalorian reveals another intriguing aspect: the ability to modulate energy output. modern directed energy weapons are developing similar capabilities. The United States Navy's laser weapon systems can be adjusted from non-lethal dazzling to destructive power, much like how blasters can be set to stun or kill. Recent advances in pulse power systems have made such adjustable energy weapons increasingly practical, though still far less portable than Star Wars blasters. The scene where Jyn Erso assembles her blaster in Rogue One shows the weapon's internal power cell, a technology that must pack incredible energy density. While we can't yet match this capability, recent breakthroughs in energy storage are promising. Scientists have developed new battery technologies using graphene and advanced materials that can store unprecedented amounts of energy in small spaces. In 2022, researchers achieved energy densities approaching theoretical limits, though still far below what a blaster would require. When we see blaster bolts impacting different materials, from punching through blast doors to being deflected by lightsabers, we're witnessing sophisticated energy-matter interactions. Modern physics is beginning to understand similar phenomena through high-energy plasma research. The ITER fusion project has shown how plasma can be controlled and directed, while studies of plasma material interactions reveal how energy weapons might affect different targets. The ability of personal shields, like those used by Droidica to stop blaster bolts, suggests fascinating principles of energy containment. Current research into plasma windows, contained fields of plasma that can block radiation and particles, shows similar possibilities. While we can't yet create personal energy shields, scientists have successfully used plasma fields to contain and redirect high-energy particles, suggesting how such defensive technology might work. Scout Troopers' blaster pistols demonstrate remarkable accuracy over distance, suggesting sophisticated guidance systems. Modern directed energy weapons face similar challenges of beam coherence and targeting. Recent developments in adaptive optics, originally developed for astronomy, show how energy beams might be kept focused over long distances. Military researchers have achieved increasing accuracy with directed energy weapons, though nothing approaching blaster precision. The compact nature of blaster power packs implies incredible energy storage efficiency. While modern batteries continue to improve, recent breakthroughs in supercapacitor technology suggest new possibilities. Scientists have created materials that can store and release enormous amounts of energy almost instantly, a crucial requirement for energy weapons. In 2023, researchers developed new electrode materials that can handle unprecedented power densities, hinting at how blaster power cells might function. When we watch Clone Wars battles, with thousands of blaster bolts filling the air, we're seeing weapons that must manage enormous heat generation. Modern directed energy weapons struggle with this challenge. Powerful lasers and plasma devices quickly overheat. Recent advances in metamaterials have created substances that can channel heat in controlled ways, while new cooling systems using microscopic channels show how compact weapons might manage waste heat. The ability of blasters to function in various atmospheres and in space demonstrates remarkable containment technology. Current plasma research faces significant challenges in different atmospheric conditions, but recent experiments with magnetic containment fields have shown promising results. Scientists have created stable plasma configurations that can maintain their properties across different pressures and environments. Perhaps most impressively, when we see blaster bolts traveling through space in battles above Scarif or Endor, we're witnessing contained plasma that can exist in vacuum. Modern physics laboratories have achieved similar, though far more limited, results. Recent experiments have created plasma filaments that can maintain coherence in near-vacuum conditions, suggesting how energy weapons might work in space. This facility is crude, but it should be adequate to freeze Skywalker for his journey to the Emperor. Darth Vader's assessment of Cloud City belies its extraordinary engineering achievement, a metropolis floating among Bespin's clouds. When we first see the gleaming spires of Cloud City emerging from the sunset-painted clouds, we're witnessing technology that modern engineering is just beginning to conceptualize. The moment when the Millennium Falcon approaches Cloud City reveals one of the most fascinating aspects of its design: the ability to maintain stability in an ever-changing atmosphere. While we can't yet build floating cities, modern science has made intriguing progress in atmospheric architecture. In 2023, researchers developed new computational models for high-altitude structures that could theoretically remain stable in varying wind conditions, similar to how Cloud City maintains its position in Bespin's upper atmosphere. When Lando Calrissian explains Cloud City's Tibanna gas mining operation, we see how the facility integrates with its environment rather than fighting against it. Modern atmospheric science is exploring similar principles through high-altitude wind power generation. Recent breakthroughs in airborne wind energy systems have demonstrated how structures could harvest energy from high-altitude winds, much like how Cloud City extracts valuable gases from Bespin's atmosphere. The massive repulsor lifts keeping Cloud City aloft represent perhaps its most impressive technological achievement. While we can't yet counteract gravity on such a massive scale, modern engineering has made surprising progress in levitation technology. Magnetic levitation already powers trains in several countries, and recent experiments with acoustic levitation have shown how objects can be suspended using sound waves. In 2022, scientists achieved stable levitation of the largest objects yet through acoustic fields, suggesting new possibilities for atmospheric structures. Cloud City's weather control systems, visible when Lando and company walk through its pristine corridors, demonstrate remarkable environmental management. Modern science is beginning to approach this level of atmospheric control, though on a much smaller scale. Recent developments in climate control technology for large structures have shown how automated systems can maintain perfect conditions even in hostile environments. The Amazon spheres in Seattle demonstrate similar principles, creating a controlled climate within transparent domes. The moment when the Millennium Falcon docks with Cloud City shows sophisticated atmospheric containment, keeping the hostile Bespin atmosphere out while maintaining breathable air within. Current research into atmospheric barriers has produced promising results. Scientists have developed new types of air curtains that can separate different atmospheric environments without physical barriers. While far from Cloud City's capabilities, these developments suggest how floating cities might manage their internal environment. When we see Cloud City's lower levels in The Empire Strikes Back, we glimpse its complex ventilation and atmospheric processing systems. Modern skyscraper design is approaching similar challenges through advanced environmental management systems. Recent breakthroughs in air filtration and circulation technology have created buildings that can process and clean enormous volumes of air, much like how Cloud City must filter Tibanna gas from its atmosphere. The city's ability to maintain stable temperature and pressure despite its high altitude demonstrates remarkable environmental engineering. Current high-altitude research stations face similar challenges. The Atacama Large Millimeter Array in Chile, operating at 16,000 feet above sea level, uses sophisticated systems to maintain stable conditions for its sensitive equipment. Recent advances in pressure management and thermal control suggest how floating cities might maintain comfortable conditions at high altitudes. Cloud City's security systems, including its shield generator, show how atmospheric cities must protect themselves from both natural and artificial threats. Modern research into atmospheric electricity and lightning protection has produced new insights into high-altitude safety systems. Scientists have developed advanced lightning protection systems that can safeguard tall structures, while recent experiments with plasma windows suggest how energy shields might one day protect floating structures. The city's power distribution system, capable of supporting a population of several million beings, represents another engineering marvel. While we can't yet power floating cities, recent breakthroughs in high-altitude solar power collection have shown promising results. In 2023, researchers demonstrated new solar collection systems that can operate efficiently in the upper atmosphere, where solar energy is more intense and consistent. When we watch ships navigating through Cloud City's airways, we see sophisticated traffic management in 3 dimensions. Modern air traffic control is developing similar capabilities for urban air mobility. Recent advances in autonomous navigation and collision avoidance systems suggest how floating cities might manage complex aerial traffic patterns. Experiments with drone swarm coordination have demonstrated principles that could apply to atmospheric city navigation. The structural engineering of Cloud City's platforms and spires must account for both atmospheric pressure changes and wind stresses. Recent developments in adaptive architecture have created buildings that can respond to environmental conditions in real time. Scientists have developed materials that can adjust their properties based on atmospheric conditions, suggesting how floating structures might adapt to changing conditions. Perhaps most impressively, Cloud City's waste management and recycling systems must operate with perfect efficiency. There's no ground to dump waste on. Modern closed-system environmental research, like that conducted in Biosphere 2, shows how such self-contained cities might function. Recent advances in waste recycling and resource recovery suggest how atmospheric cities could maintain sustainable operations. The city's ability to harvest water directly from its atmosphere mirrors emerging technologies in atmospheric water generation. While current systems can extract only limited amounts of water from air, recent breakthroughs in materials science have created substances that can efficiently capture atmospheric moisture. In 2022, scientists developed new materials that can extract water from even very dry air, suggesting how floating cities might maintain their water supply. Red 3. Standing by. When we watch X-Wings and TIE fighters dance through space during the Death Star trench run, we're seeing combat that often defies real physics. Yet beneath the fantasy, Star Wars space battles occasionally illuminate fascinating truths about how real space combat might work. The physics of warfare in vacuum presents challenges that even the Empire's mighty fleet must respect. The opening battle of Revenge of the Sith shows massive capital ships exchanging broadsides above Coruscant, behaving more like ancient sailing vessels than spacecraft. Real space combat would look vastly different. Modern physics tells us that objects in orbit never truly stop moving. They're constantly falling around their planet at kilometers per second. Recent satellite intercept tests have demonstrated the incredible precision needed for spacecraft to meet in orbit, with closing velocities often exceeding 20,000 miles per hour. When the Millennium Falcon emerges from hyperspace during the Battle of Endor, we see one of the rare moments where Star Wars acknowledges orbital mechanics. The ship must adjust its velocity to match the battlefield, much like how real spacecraft must perform careful burns to rendezvous with their targets. NASA's recent DART mission demonstrated these principles when it precisely intercepted an asteroid, showing how space combat would require incredible calculations to line up shots. TIE Fighter's distinctive twin ion engines hint at real technology currently used in space. While modern ion engines produce far less thrust, they're incredibly efficient. The Dawn spacecraft used ion propulsion to change its velocity by over 25,000 miles per hour during its mission, demonstrating how real space combat might involve long, efficient burns rather than quick dogfighting turns. In 2023, new ion engine designs achieved record-breaking specific impulse, suggesting how future space fighters might maneuver. The Battle of Scarif demonstrates another fascinating aspect of space combat: the challenge of three-dimensional warfare. Unlike atmospheric combat, space battles have no natural up or down. Modern satellite warfare planning accounts for this reality. Recent anti-satellite weapon tests have shown how orbital combat would occur in all directions, with attacks potentially coming from any angle. The United States Space Force now trains using software that models true three-dimensional space warfare. When we watch star destroyers looming over planets, we're seeing ships that would actually be fighting intense gravitational forces. Real spacecraft in low orbit must constantly balance velocity against gravity. Too slow and they fall, too fast and they escape. The International Space Station maintains this delicate balance, adjusting its orbit regularly to compensate for atmospheric drag. Recent developments in orbital mechanics software have shown how space warships would need sophisticated systems just to maintain stable orbits during combat. The destruction of the Death Star shows another orbital physics principle: debris propagation in space. While the explosion itself is unrealistic, in vacuum there would be no visible shockwave, the scatter of debris demonstrates a real concern in space warfare. When China destroyed a satellite in 2007, the resulting debris cloud expanded to threaten other spacecraft. Modern space combat planners must consider how destroyed targets create hazards that can last for decades. Y-wing bombing runs against Imperial capital ships ignore a crucial reality of space combat: weapon velocity. In space, every projectile fired inherits the velocity of its launching ship. Recent kinetic kill vehicle tests have shown how space weapons would need to account for both the shooter's and target's orbital velocities. In 2022, scientists calculated that even small objects in orbit could impact with the force of artillery shells due to their extreme velocities. The Clone Wars space battles show massive fleets maneuvering like naval vessels, but real space combat would involve much more complex orbital choreography. Modern satellite operators must calculate precise orbital dynamics for even simple maneuvers. Recent advances in autonomous satellite navigation have demonstrated how future space warships might calculate complex orbital intercepts in real time. When Imperial ships launch fighters, we see them treated like aircraft launching from carriers. In reality, launched spacecraft would immediately enter their own orbits. Recent developments in small satellite deployment have shown how released objects follow orbital mechanics, not atmospheric flight patterns. CubeSat deployments from the International Space Station demonstrate the complex calculations needed to safely release spacecraft in orbit. The Death Star's ability to maintain position above Yavin 4 without falling into the gas giant demonstrates incredible power requirements. Real spacecraft must constantly balance gravitational forces from multiple bodies, a principle called the N-body problem. Recent breakthroughs in computational orbital dynamics have helped us understand how spacecraft can maintain stable positions in complex gravitational fields, like NASA's James Webb Space Telescope at the Earth-Sun L2 point. Laser weapons in Star Wars travel slower than real light, but actual space-based laser weapons would be instantaneous. Modern directed energy weapon research shows how space-based lasers would be limited more by beam coherence and power requirements than travel time. Recent experiments with ground-based laser systems have demonstrated both the potential and limitations of energy weapons in space. Perhaps most intriguingly, when the Rebel fleet coordinates its attack on the second Death Star, we see the challenges of communication in space combat. Real space warfare would face significant communications delays due to light speed limitations. Recent developments in quantum communications have shown potential ways to coordinate space forces more effectively, though still bound by physical laws. The massive explosions we see in space battles ignore the reality of vacuum combat. Without atmosphere to propagate shock waves or carry sound, real space combat would be eerily silent and visually different. Recent space debris impact studies have shown how spacecraft actually behave when damaged in vacuum, with materials behaving very differently than in atmosphere. While Star Wars space combat often prioritizes drama over physics, studying real space warfare principles provides fascinating insights into how future conflicts might actually unfold in the void. Each aspect of space combat, from orbital mechanics to weapon effectiveness to debris management, represents a frontier that modern military space programs are actively exploring. As our understanding of orbital dynamics, space-based weapons, and spacecraft design advances, we move slightly closer to real space warfare capabilities, though thankfully still far from Star Destroyers and Death Stars. The engineering and physics challenges posed by space combat continue to drive innovation in fields from satellite design to orbital mechanics, showing how science fiction can inspire real technological progress while reminding us of the vast differences between fantasy and reality. He's more machine now than man, twisted and evil. Obi-Wan's description of Darth Vader hints at one of Star Wars' most fascinating technological achievements: a full-body life support system that kept a catastrophically injured human alive for decades. When we first hear Vader's iconic breathing, we're witnessing a complex medical system that modern science is just beginning to approach. The moment in Revenge of the Sith, when Vader first awakens in his suit, reveals the extent of Imperial medical technology. Surviving third-degree burns over most of his body, lost limbs, and severe lung damage would challenge even modern medicine. Yet recent breakthroughs offer hope for similar trauma victims. In 2023, researchers developed new synthetic skin with integrated nerve connections, while advanced burn treatment protocols have dramatically improved survival rates for severe burn victims. When we see Vader's meditation chamber in The Empire Strikes Back, we glimpse the sophisticated environmental controls keeping him alive. The chamber's pressurized atmosphere allows him to briefly remove his mask, suggesting similar principles to modern hyperbaric oxygen therapy. Recent advances in atmospheric control systems have created increasingly sophisticated medical environments. In 2022, scientists developed new air filtration and pressure control systems for treating severe respiratory conditions, approaching the level of environmental control Vader's chamber provides. Vader's prosthetic limbs demonstrate incredibly sophisticated human-machine integration. While we see him effortlessly wielding a lightsaber or force-choking Imperial officers, modern prosthetics are achieving remarkable advances in fine motor control. Recent developments in neural interfaces have allowed amputees to control robotic limbs with their thoughts, while advanced sensory feedback systems can provide tactile sensations. In 2023, researchers successfully created prosthetic fingers with sense of touch rivaling human skin. The suit's ability to manage Vader's chronic pain represents another medical marvel. Modern pain management is exploring similar principles through advanced neurostimulation. Recent breakthroughs in targeted nerve stimulation have shown promise in treating severe chronic pain without medication. The development of smart pain management systems that can adjust their response based on real-time neural feedback suggests how Vader's suit might help him function despite constant pain. When Vader fights Obi-Wan aboard the Death Star, we see his suit maintaining perfect mobility despite its life support functions. Modern powered exoskeletons are approaching this capability, though on a much simpler scale. Recent advances in mechanical assistance systems have created suits that can help paralyzed individuals walk again. In 2022, researchers developed new actuator systems that could respond to neural signals with near-natural speed, suggesting how full-body mechanical assistance might work. The neural interfaces controlling Vader's prosthetics must process enormous amounts of sensory and motor information. Modern brain-computer interfaces are making remarkable progress in this direction. Recent breakthroughs in neural implant technology have allowed direct communication between human brains and computers. Companies like Neuralink have developed increasingly sophisticated neural interfaces, though still far from the seamless integration of Vader's systems. Vader's suit monitors and maintains every aspect of his physical condition, from blood chemistry to organ function. Modern medical monitoring is approaching similar capabilities through advanced biosensors. Recent developments in continuous health monitoring have created systems that can track multiple vital signs simultaneously and adjust treatment automatically. In 2023, researchers developed microscopic sensors that can monitor organ function in real time, suggesting how comprehensive medical monitoring might work. The respiratory system that produces Vader's distinctive breathing sound represents sophisticated artificial lung function. While current artificial lung technology requires large external machines, recent breakthroughs in miniaturization show promise. Scientists have developed increasingly compact oxygenation systems, while advances in artificial lung tissue suggest how damaged lungs might be supplemented or replaced. The development of portable ECMO systems shows how life support could become more mobile. When Luke damages Vader's suit during their fight on Cloud City, we see the system's remarkable self-repair capabilities. Modern medical technology is developing similar self-maintaining systems. Recent advances in self-healing materials and adaptive medical devices have created systems that can compensate for damage or malfunction. Smart materials that can repair themselves suggest how critical life support systems might maintain function even when damaged. Vader's ability to consume nutrients despite severe digestive system damage suggests sophisticated artificial digestion and nutrition systems. Current medical science is making progress in artificial organ function. Recent developments in artificial stomach and intestinal systems have shown how complex biological processes might be replicated mechanically. The development of advanced nutrient delivery systems suggests how complete artificial digestion might work. The suit's temperature regulation system keeping Vader alive despite his compromised ability to thermoregulate demonstrates another sophisticated medical function. Modern environmental suits are approaching similar capabilities. Recent advances in smart fabric technology have created materials that can actively regulate temperature, while new cooling systems can respond instantly to body temperature changes. The development of precision temperature control for medical applications suggests how full body temperature regulation might function. Perhaps most impressively, all these systems must work in perfect coordination to keep Vader alive. Modern medical integration systems are beginning to show how this might be possible. Recent developments in artificial intelligence for medical systems have created increasingly sophisticated coordination between different treatment systems. The emergence of smart medical systems that can balance multiple treatment priorities suggests how complex life support might be managed. Help me, Obi-Wan Kenobi. You're my only hope. Princess Leia's flickering blue hologram message, projected by R2-D2, represents one of science fiction's most iconic images. Yet the physics behind this seemingly magical technology, three-dimensional images floating in free air, is something modern science is beginning to understand. When Emperor Palpatine's enormous hologram looms over Snoke's throne room, we're seeing something that challenges our understanding of light manipulation. While we can't yet create free-floating holograms of that scale, recent breakthroughs have shown promising results. In 2023, researchers developed new volumetric display technology that can create true 3D images in air using focused laser light. While far smaller than Star Wars holograms, these images can be viewed from any angle without special glasses. The moment when the Rebel Alliance reviews the Death Star plans shows another fascinating aspect of holographic technology: the ability to manipulate and interact with 3D data in real time. Modern volumetric displays are approaching this capability. Recent developments in light field technology have created displays where multiple viewers can see different perspectives of the same 3D image simultaneously. When General Dodonna points out the thermal exhaust port, we're seeing the kind of tactical planning that modern military commands dream of achieving. The Star Destroyer bridge's holographic communications demonstrate sophisticated data transmission and reconstruction. While current video calls remain stubbornly two-dimensional, scientists have made remarkable progress in holographic transmission. In 2022, researchers successfully transmitted holographic data over standard internet connections, reconstructing 3D images at the receiving end. This suggests how real-time holographic communication might eventually work, though still far from the clarity of Imperial communications. When Snoke's hologram disappears after speaking with Kylo Ren, we see another crucial aspect of this technology: the ability to instantly project and dissolve complex 3D images. Modern holographic research is exploring similar capabilities through advanced light manipulation. Recent breakthroughs in photonic crystals have shown how light can be precisely controlled to create and remove 3D images almost instantly. The development of switchable holographic materials suggests how images might be rapidly formed and erased. The Death Star's conference room shows multiple officers viewing the same hologram from different positions, each seeing the correct perspective. Current holographic displays are beginning to achieve similar results through light field technology. Recent advances in multi-view displays have created systems where dozens of viewers can each see the correct 3D perspective without wearing special equipment. While limited in scale, these developments suggest how group holographic viewing might work. Leia's hologram message demonstrates remarkable data compression, storing a high-resolution 3D recording in a form that R2-D2 could carry and project. Modern holographic data storage is making similar advances. Scientists have developed new materials that can store incredible amounts of data in crystalline structures, with recent breakthroughs achieving storage densities thousands of times greater than conventional hard drives. In 2023, researchers demonstrated holographic storage systems that could preserve complex 3D data with perfect fidelity. When we see tactical holograms during space battles, showing real-time 3D positions of ships and fighters, we're witnessing sophisticated data processing and display technology. Modern military command and control systems are working towards similar capabilities. Recent developments in volumetric radar displays have created systems that can show true 3D positions of aircraft and vessels, though not yet with Star Wars clarity. The integration of AI-driven data processing suggests how complex 3D battlefield information might be displayed. The distinctive blue color of most Star Wars holograms hints at the use of specific wavelengths of light for transmission and display. Current holographic research shows why this might be practical. Recent experiments with coherent blue laser systems have demonstrated superior results in creating visible 3D images in air. The development of new blue light photonic materials suggests why this particular part of the spectrum might be ideal for holographic projection. When Qui-Gon Jinn communicates via hologram in The Phantom Menace, we see how the technology handles motion and real-time interaction. Modern motion capture for holographic displays is making remarkable progress. Recent breakthroughs in light field cameras have created systems that can capture 3D motion in real time for holographic reconstruction. The development of advanced image processing algorithms suggests how fluid holographic motion might be achieved. The ability of Star Wars holograms to function in various environments, from desert planets to space stations, demonstrates sophisticated environmental adaptation. Current holographic display research faces similar challenges. Scientists have developed new methods for compensating for atmospheric interference and varying light conditions. Recent advances in adaptive optics, originally developed for astronomy, show how holographic systems might maintain clarity in different environments. Perhaps most impressively, when we see massive tactical displays during the Battle of Endor, we're watching holographic technology scale from personal messages to room-filling strategic displays. Modern research into scalable holographic systems shows similar versatility. Recent developments in modular holographic displays suggest how systems might be scaled from personal devices to large-scale installations. The emergence of new projection technologies hints at how variable-scale holograms might work. The holographic disguise technology used by Obi-Wan in the Clone Wars suggests even more sophisticated light manipulation. While we can't yet create holographic camouflage, recent developments in metamaterials have created surfaces that can manipulate light in unprecedented ways. Scientists have developed materials that can bend light around objects, suggesting how holographic invisibility or disguise might eventually be possible. The roar of TIE fighters echoing through space, the thunderous explosion of the Death Star, the distinctive hum of lightsabers clashing in the void between stars. While these iconic sounds have become inseparable from Star Wars' identity, they represent one of science fiction's most fascinating departures from reality. Yet, as we'll discover, space isn't quite as silent as we once thought. In the vacuum of space, no one should hear your X-Wing scream. Sound waves, unlike light or radio waves, require a medium to travel through, typically air molecules that bump into each other, creating a chain reaction that eventually reaches our ears. In the near-perfect vacuum of space, with an average density of just one hydrogen atom per cubic centimeter, traditional sound waves simply can't propagate. So why does Star Wars, like many science fiction franchises, fill its space battles with such rich soundscapes? The answer lies in human psychology and storytelling. Ben Burtt, the legendary sound designer for Star Wars, once explained that complete silence during space scenes would feel artificial to audiences, even though it would be scientifically accurate. Our brains expect audio-visual correlation. When we see an explosion, we expect to hear it. This expectation is so deeply ingrained that silent space scenes can actually break audience immersion rather than enhance it. But recent scientific discoveries have revealed that space isn't as silent as we once believed. In 2003, NASA's Chandra X-ray Observatory detected sound waves emanating from a supermassive black hole in the Perseus galaxy cluster. These waves, propagating through the hot gas surrounding the black hole, have a frequency corresponding to a B-flat note, about 57 octaves below middle C. While far too low for human ears to detect, this cosmic bass note shows that sound can exist in space, just not in the way we traditionally think about it. In fact, space is filled with various types of waves that, while not technically sound, can be converted into audible frequencies. NASA's Van Allen probes have recorded what scientists call chorus waves, electromagnetic waves produced by energetic electrons in Earth's magnetosphere. When converted into sound waves, they create an eerie whistling reminiscent of birdsong. Similarly, the interaction between solar wind and planetary magnetic fields produces magnetosonic waves that, when translated into audio, sound surprisingly similar to the deep rumble of Star Wars Imperial Star Destroyers. The physics of explosions in space also differs dramatically from their portrayal in Star Wars. Without air to carry sound waves or provide resistance, real space explosions would be largely silent and would look different too. The iconic Death Star explosion, with its expanding fireball and outward propagating sound wave, couldn't happen exactly as shown. In reality, the explosion would be more of a rapid expansion of debris and gas, silent and somewhat less visually dramatic, though potentially more deadly due to the unimpeded spread of shrapnel through space. However, if you were inside a spaceship during a space battle, you would hear some sounds. The impacts of laser bolts or debris hitting your ship would propagate through the ship's structure and atmosphere, reaching your ears as very real vibrations. This is similar to how astronauts on the International Space Station can hear impacts from micrometeoroids striking the station's hull. The sound wouldn't travel through space to reach you, but rather through the materials of your own vessel. Modern space exploration has given us a better understanding of how sound-like phenomena manifest in space. The European Space Agency's cluster mission discovered that the Earth's magnetosphere acts like a giant speaker, producing ultra-low frequency waves that, when accelerated thousands of times, sound remarkably like nature's own version of Star Wars sound effects. These electromagnetic ion cyclotron waves create patterns that, when converted to audio, resemble the whoosh of spacecraft passing by. The concept of sound in space becomes even more interesting when we consider the different mediums that do exist in space. While the vast majority of space is nearly empty, there are regions where matter is dense enough to transmit sound-like waves. The solar corona, for instance, supports magnetohydrodynamic waves that behave similarly to sound waves in air. These waves, discovered by NASA's SOHO spacecraft, travel at speeds around 300 kilometers per second and play a crucial role in heating the sun's outer atmosphere. Interstellar space itself contains extremely diffuse plasma that can support very long wavelength oscillations. These plasma waves, while not sound in the conventional sense, represent a kind of space weather that can affect everything from satellite communications to power grids on Earth. The Voyager spacecraft have detected these waves in the outer solar system, creating what scientists call the heliospheric symphony. Even the famous lightsaber hum, while impossible in the vacuum of space, has an interesting parallel in modern physics. Plasma contained within magnetic fields, similar to what we use in fusion reactors, can produce oscillations that create audible frequencies. While not exactly the distinctive lightsaber sound, these plasma waves demonstrate how energy fields can indeed generate sound-like phenomena. The future of space exploration might actually benefit from our growing understanding of space acoustics. NASA engineers are developing ways to use sound-like waves to monitor the health of spacecraft systems and detect micrometeoroid impacts. Some scientists even propose using acoustic waves in the thin atmosphere of Mars for communication, as these waves could potentially travel long distances in the planet's carbon dioxide atmosphere. So, while Star Wars takes creative license with its space sound effects, the reality of cosmic acoustics proves equally fascinating. From black hole-based notes to electromagnetic choruses, the universe has its own soundtrack, one that's only now beginning to be heard and understood by human ears. As we continue to explore space, we're discovering that while George Lucas's space fantasy got the specifics wrong, its suggestion of a universe filled with vibration and energy wasn't entirely off the mark. When Luke Skywalker first gazes at Tatooine's binary sunset, we witness one of science fiction's most iconic moments. But this seemingly fantastical scene, a habitable planet orbiting two suns, has proven remarkably prescient. In 2011, NASA's Kepler Space Telescope discovered Kepler-16b, the first confirmed circumbinary planet, proving that planets can indeed orbit multiple stars, just like Luke's home world. The stunning diversity of Star Wars planets, from the frozen wastes of Hoth to the searing deserts of Jakku, might seem like pure imagination. Yet as our exploration of the galaxy continues, we're discovering that the universe harbors worlds even stranger than those in George Lucas's imagination. Take WASP-76b, discovered in 2020, where it rains molten iron from clouds of vaporized metal. This extreme world makes even Mustafar's lava flows seem tame by comparison. The concept of a desert planet like Tatooine once seemed far-fetched. How could a world with so little water support life? But recent discoveries have shown that desert worlds might be more common than we thought. In 2021, astronomers using the TESS telescope identified TOY 1452b, a potential ocean world that could be gradually losing its water to space, potentially becoming a desert planet. The process mirrors what we believe happened to Mars, suggesting that desert worlds might be a natural part of planetary evolution. Hoth's frozen landscape finds real parallels in our own solar system with Europa, Jupiter's ice-covered moon. While Europa's surface temperatures of -260 degrees Fahrenheit make Hoth look positively balmy, both worlds demonstrate how life might adapt to extreme cold. Recent evidence suggests Europa harbors a liquid ocean beneath its icy crust, heated by tidal forces, much like how Star Wars rebels could survive in Hoth's ice caves, warmed by geothermal energy. The forest moon of Endor, home to the Ewoks, represents a type of world that might be more common than we once thought. Studies of habitable zones around red dwarf stars suggest that moons orbiting gas giants could provide stable environments for life. The TRAPPIST-1 system, discovered in 2017, contains several Earth-sized planets that could potentially host Endor-like environments, complete with dense forests and complex ecosystems. Coruscant's city-covered surface might seem like pure fantasy, but it raises fascinating questions about planetary engineering. While we're far from building planet-spanning cities, scientists are already discussing concepts like orbital rings and space elevators, technologies that would be necessary for a planet to support the kind of infrastructure we see on Coruscant. The discovery of super-Earths, planets with greater mass and surface gravity than Earth, has led to discussions about how architecture and transportation would need to adapt on high-gravity worlds. The volcanic world of Mustafar has a real-world counterpart in K2-141b, an exoplanet discovered in 2020. This extreme world has a surface partially covered in lava oceans, with temperatures hot enough to vaporize rock, creating a volatile atmosphere of vaporized silicon and minerals. While not quite as hospitable as Mustafar, which somehow maintains breathable atmosphere despite its volcanic nature, K2-141b shows that volcanic worlds are very real and even more extreme than their Star Wars counterparts. The gas giant Bespin, home to Cloud City, finds parallels in our understanding of gas giant atmospheres. Jupiter's upper atmosphere contains layers where pressure and temperature would theoretically allow for floating structures. Recent studies of superpuff exoplanets, gas-rich worlds with extremely low density, suggest that habitable layers within gas giant atmospheres might be more common than previously thought. Kamino's endless oceans seemed impossible when Attack of the Clones was released, but we now know that ocean worlds might be common in our galaxy. Research from NASA's Goddard Space Flight Center suggests that many of the exoplanets we're discovering could be completely covered in deep oceans. The TRAPPIST-1 system alone might contain multiple water worlds, though probably none with the sophisticated cloning facilities of Kamino. The concept of habitable zones, the region around a star where conditions might support life, has evolved significantly since Star Wars was created. We now know that factors beyond simple distance from a star, such as planetary magnetic fields, atmospheric composition, and geological activity, play crucial roles in habitability. The discovery of extremophiles on Earth, organisms that thrive in conditions that would kill most life forms, has expanded our understanding of what constitutes a habitable environment. Perhaps most intriguingly, recent research suggests that binary star systems like Tatooines might actually be promising places to look for life. While early models suggested that planets in binary systems would have unstable orbits, we now know that many binary stars could support habitable planets. The combined light from two stars might even provide advantages for photosynthesis, potentially supporting more robust plant life than single-star systems. The atmospheric composition of exoplanets has become a key area of study, with new technologies allowing us to analyze the chemical signatures of distant worlds. While Star Wars depicts most planets with breathable atmospheres, reality shows greater variety. Some exoplanets have atmospheres rich in hydrogen, others in carbon dioxide, and some appear to have metal vapors in their air. The James Webb Space Telescope, launched in 2021, is revolutionizing our understanding of exoplanet atmospheres, detecting everything from water vapor to organic compounds. As we continue to explore our galaxy, the line between science fiction and reality grows increasingly blurred. While we haven't found any planets quite like those in Star Wars, our discoveries suggest that the universe contains worlds even more diverse and extreme than those imagined by George Lucas. From iron rain to lava oceans, from water worlds to super Earths, the real galaxy proves to be every bit as fascinating as the one far, far away. The Empire Strikes Back opens with a stark vision of environmental extremes. The ice planet Hoth, where temperatures plunge so low that even tauntauns freeze solid. Meanwhile, across the galaxy, Tatooine's twin suns bake its endless deserts. While these worlds might seem like exercises in science fiction extremes, they offer fascinating parallels to real planetary climate science, and in some cases, the reality proves even more extraordinary than fiction. Let's start with Hoth. The Rebel Alliance chose this frozen world for its base precisely because its hostile environment made it an unlikely Imperial target. But how cold would Hoth actually need to be to match what we see on screen? When Han Solo rescued Luke by cutting open a tauntaun for shelter, the animal's internal fluids froze almost instantly, suggesting temperatures well below -40 degrees Fahrenheit, the point at which most biological fluids freeze. However, this creates a fascinating scientific paradox. How does a planet cold enough to flash freeze organic matter maintain an atmosphere thick enough to breathe? The answer might lie in our own solar system. Saturn's moon Titan maintains a thick atmosphere despite surface temperatures of -290 degrees Fahrenheit. The key difference is composition. Titan's atmosphere is primarily nitrogen and methane rather than oxygen. A real-world Hoth would likely need a similar atmospheric composition, perhaps with enough oxygen mixed in to support human life. Recent exoplanet discoveries, like WASP-43b, demonstrate how extreme temperature variations can exist on worlds while maintaining stable atmospheres. The ice caves where the rebels established Echo Base have real-world analogues in Antarctica's volcanic ice caves. On Mount Erebus, geothermal heat creates and maintains cave systems within the ice, where temperatures can be warm enough to support life despite the frigid surface conditions above. Scientists studying these environments have discovered unique ecosystems that might hint at how life could adapt to Hoth-like conditions. In 2021, researchers at the University of Chicago demonstrated how certain chemical compounds can create warm spots within ice, potentially explaining how life might persist in frozen environments. These microenvironments, combined with geothermal heating, could theoretically support the kind of ecosystem we see on Hoth, including the wampus and tauntauns that somehow survive its brutal climate. Shifting to the opposite extreme, Tatooine presents its own set of fascinating climate challenges. A planet orbiting binary stars would experience complex seasonal patterns and temperature fluctuations. Recent studies of real binary star systems, like Kepler-35, suggest that circumbinary planets can maintain stable climates, but they would experience unique meteorological phenomena unknown on Earth. The most immediate challenge for a desert world like Tatooine would be water retention. In 2022, scientists using the James Webb Space Telescope analyzed the atmosphere of a hot, desert-like exoplanet named GJ367b. Their findings suggested that intense stellar radiation can strip away light elements like hydrogen and oxygen, potentially explaining how planets lose their water over time. This process, known as atmospheric escape, might explain Tatooine's extreme aridity. Yet Tatooine clearly maintains enough moisture to support life, as evidenced by the moisture farms where Luke grew up. This apparent contradiction might be explained by recent discoveries about Mars' water cycle. Though Mars appears bone dry on the surface, substantial water ice exists just below ground. Similarly, Tatooine might harbor underground aquifers protected from its harsh surface conditions. The sand dunes that dominate Tatooine's landscape follow real physical principles. Studies of desert formation on Earth, particularly in the Sahara and Namib deserts, show how wind patterns and particle size create and maintain dune seas. The massive dunes we see in A New Hope could indeed form naturally, shaped by Tatooine's complex wind patterns created by its binary star heating system. Temperature extremes on both planets present interesting challenges for technology. On Hoth, the extreme cold caused the Rebels' speeders to malfunction, a realistic problem that mirrors issues faced by real spacecraft and polar expeditions. Modern space technology must cope with temperature swings of hundreds of degrees as satellites move between sunlight and shadow. The solutions developed for real space exploration, like multi-layer insulation and heating systems, would be essential for survival on either world. Recent climate modeling has shown that planets can exist in stable snowball or desert states. Earth itself has experienced snowball periods in its distant past, where ice covered most or all of its surface. Conversely, during the Permian period, much of Earth's surface was desert, creating conditions not unlike Tatooine. These historical climate extremes help us understand how planets can maintain such conditions for long periods. The presence of life on both worlds raises intriguing questions about adaptation. Studies of extremophiles on Earth provide clues about how organisms might survive such harsh conditions. In Chile's Atacama Desert, one of the driest places on Earth, microorganisms have evolved to extract water from mineral crystals. Similar adaptations might explain how Tatooine's creatures survive. Meanwhile, Arctic and Antarctic organisms produce biological antifreeze compounds that could parallel adaptations on Hoth. Perhaps most fascinating is how these extreme environments affect atmospheric circulation. On Hoth, the constant snow cover would create unique weather patterns. When air masses of different temperatures interact over snow-covered surfaces, they can produce phenomena like diamond dust, tiny ice crystals that hang in the air, creating optical effects like sundogs and light pillars. These might explain some of the atmospheric effects we see in Empire Strikes Back. On Tatooine, the intense heat from two suns would create powerful convection currents, leading to frequent dust storms like the one that concerned Uncle Owen before he purchased R2-D2. Similar dynamics occur on Mars during its dust storm season, though Tatooine's thicker atmosphere would make its storms even more intense. Recent Mars research has helped us understand how such storms can become self-sustaining, potentially lasting for weeks or months. As our understanding of planetary climate science expands, worlds like Hoth and Tatooine seem less like science fiction and more like extreme examples of real possibilities. While some aspects of their portrayal bend the laws of physics, the core concepts, frozen worlds, and desert planets align surprisingly well with what we're discovering about the incredible diversity of planetary environments in our galaxy.